I don't even have Hunter yet. Okay. All right, so what we're going to do is we're going to go ahead and go over our independent and dependent events worksheet first. There he comes. All right, I knew something was up. Hunter's never know. Turn this, and there they are. Hello, how are y'all, ladies? Good. All right. All right. How are you today, Hunter? All right, so the first thing that we're going to be doing today is going over our independent and dependent events worksheet. Okay, we're going to go over our answers on these. Then we're going to be doing our unit review to get ready for our test. So I'll give y'all a chance to get all that out. So the first thing we need to have out is our worksheet on independent and dependent events. Let's see. So he's having trouble with that. Okay, so we started off talking about independent and dependent events. We said that independent events are events that can happen independent of each other. One does not depend on the other. The outcome of one does not affect the outcome of the event to follow right after. Waiting to see if Hunter can hear me. I think he's having trouble with his camera and microphone. And then we said, okay, perfect. If you can't get it figured out, Hunter, then feel free to text me if you have questions. If you need to, or if you need to disconnect and try to reconnect, it's totally up to you. But anyway, so if you have questions, so you can just text me, and then we'll just go from there. Does that work okay for y'all? Okay. All right, so we said independent events are events that can happen. The result of that event does not change the result of the following events. But then our dependent events are the ones that when I have the result of one event and then I do something right after, then my results change because I have to change the values of my possible, and looking at my independent events are going to change based on the previous event that has happened. So we left off in our homework, I think was section 4 or activities, or number 4 on independent and dependent events. So number 4 and then number 5 was doing reverse of everything. So let's take a look at number 4 and let's talk about how we set you choose cards from a standard deck of cards one at a time without replacing them. So basically we're looking at A through H as all separate. Okay, but in A, I start reach in, I draw a card, and I'm trying to get an ace. So we said the probability of getting an ace 4 out of 52. Then do not put that ace back, and we draw and reach in again, and we want to. Now we've had to alter our number of cards. So the probability of getting a king is going to be 4 out of 51. Okay, so when we multiply out of 52 times 4, I end up with 16,652. And if you did, the simplified answer would be 4 over 663. If you did not simplify it, that is okay. We are dealing with such large numbers right now that we will not worry about simplifying. If you did, that's fantastic. But with these large numbers, I would not count off. All right, the next one, letter B. Again, we're starting all over, 52 cards total. You draw and you're trying to get a heart, and then draw for a diamond. So the first thing is I start with 52 cards and I'm trying to get a heart. How many hearts am I going to have in my deck? 13 hearts. Good. So I reach in. So that's 13 out of 52. Now I have my card that I pulled out, and now I'm trying to get a diamond. So how many possible diamonds do I have? 13 again, out of how many possible cards? 51. Good. So again, 13 over 52 times over 50. Any questions on C? 2 hearts in a row. Okay, so the first time I reach in, draw. How many hearts do I have? 13 out of 52. Now I'm reaching in and I'm going to try to draw another heart. So let's say I reached in and the one I got was a heart. Now, one of my hearts is out of my total stack. So how many hearts do I have now? 12 out of how many totals? 51. Good. So on that one, we're going to have to multiply, and we've got 13 times 12. So 13 times 12 be 156 over 2,652. Obviously, we can see these are even. You could simplify. Let me make sure I did that right. So 13 times 12, 156 over 2652. You'd, let's see, divide by 2. I would end up with 78 over 1326. And then I could divide that by 2. And I've got 39 over 663. Those are both going to be divisible by 3. So I'm going to end up with 13 over 221 if you simplified. If you didn't, no worries. All right, so we looked at what we would do with 2 hearts in a row, and we said we know there's 13 of each out of 52, and we looked at that. Now look at letter D. You get 2 kings in a row. How many kings are in a deck of cards? 4. 4 kings out of 52 is going to be 4 out of 52. My next one, if I'm to get another king, how many kings will I have? 3 out of what? 50. Good, out of 50. So I have 4 out of 52 times 3 out of 50 is going to give me 12 over 2,652. Again, I can divide by 2, and I would get 6 over 1,326. Now I can divide by 2 again, and 3, so 1326 divided by 2, we said was 663. And then I can reduce that, and that ends up 1 out of 221 if you reduced it all the way. Letter E. So this time, previously we've been drawing and we've been doing 2 draws. Now I'm looking at what it would be like to have 3. First time I draw, how many queens do I have? 4. So I have 4 out of 52. Second time I draw, what's the probability? 3. 1. And now my third draw, what is my probability? 2 out of 50. Good. 3 times 2, so that's going to be 4 over 52 times 51 times 50 is 132,600. let's see what that's going to be reduced. Let's see, that divided by 2 will be 66,300. It's going to be 12. We'll divide that by 2. That's going to be 33,150. Divide that by 2. 16,575. That's going to be, let's see, 3, and it is not. So my final solution on that I reduced on letter E is going to be 3 out of 16,575. That's if you reduced it all the way. Again, you could have left it where you had, what do we say, 24 out of 132,600. Okay. Letter F. You get the king of diamonds and then the king of clubs. Okay, so how many king of diamonds do I have? 1. How many king of clubs do I have? 1. So the first time I've got 1 out of 52. My second time I only have 1 out of 51. So 1 times 1 is 1. And we said that 52 times 51 is 2,652. So think about that for a minute. If I only have 1 chance out of 2,652 possibilities, are those good? Are those good? Is that good, or is it do you have a high probability of drawing a card or low probability? Low, isn't it? Yeah, yeah. So definitely going to be a slim chance that happens. Still a chance, but it's a chance. All right. At letter G again. Now this time I'm drawing 4 aces a row. What is my first probability on my first draw? 4 out of 52 will be 3 out of 51. My third draw, 2 out of 50. And then my fourth draw, 1 out of 49. Oh my goodness. So we have total of 24 chances, or my chance of it occurring. I've got 24 out of 50. 51 times 6,497,400. 6,497,400. Let's see what that would reduce to. Let's see. So let's see. 6, 3. Oh, go back. Okay, so let's look at this for a minute. Our probability in letter, is it F we were talking about? Letter F, we said our probability was 1 out of 2,652. Now look at letter G. G, I started out with 24 out of 6,497,400. And when I reduce that, I can divide both by 24. And my reduced is going to be 1 out of 270,725. So think about that for a minute. Do you have a better chance of getting the king of diamonds and then the king of clubs, or 4 aces in a row? Which one do you have a better chance at? No. Yeah, I have a better chance of this happening, and it's not very good, is it? But when we compare the two, we can look and see how they do compare. Okay, good. Now let's look at letter H. Okay, So in letter H, one of the things that I can't remember if we caught in class or not. So when you have a deck of cards, okay, so it says a picture card and then a not picture card, and they have in parentheses 1 through 10. There is not a 1. Okay, so then I was confused and I thought, well, are they counting the ace as a picture card or as a number card? But since an ace is not a number, I said, well, we're going to count that as a picture card. Okay, so our picture cards, we had to have a jack, queen, king, and ace. So we have 4 picture cards. Let's see, this is what, letter H. So I said we have 4 picture cards, but then when we talk about number cards, there's not a number 1 in a set of cards. It starts with number 2. So we only have 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's actually 9 number cards. Okay, because remember we said we have 13 total per suit. Okay, so each suit of like kings, goodness, diamonds, spades, clubs, hearts, whatever. There's 13 total cards. So I've got to think about that. 4 of those are picture cards and 9 of them are number cards. Okay, so that's some of the things that I realized, I think afterward, that we did not discuss before I sent you home to do homework. So let's go ahead and adjust this one. So what are my chances of drawing a picture card here? How many picture cards do I have?
4.
Okay, I have 4 picture cards, but how many suits do I have? So I have 4 picture cards in diamonds, and I have 4 picture cards in hearts, and 4 picture cards in clubs, and 4 picture cards in spades. So how many total picture cards do I have? 16, good. So 16 out of 52 cards are picture cards. Okay, so that's going to be my first one. How many number cards do I have?
9.
9 per suit. How many suits do I have?
4.
4. So how many total number cards do I have? 36. Good. So now I've got actually, I'll go ahead and put this right here so we can look at it. Okay, so 4 picture cards are 16 out of 52. Number cards, we have 36 out of 52. And then obviously if we add 16 and 36, that equals 52. So our total deck. Okay, so the first time I draw, I get a picture card. Okay, so that was our 16 out of 52. My second draw, a not picture card. Okay, so how many picture cards, how many number cards do I have or non-picture cards? 16, but how many cards? Oh, no,
36.
36, yep. We've got 36 that are not picture cards, but how many cards do we have in there?
52.
No, after we've done our first draw, we would only have 51, right? So now we've got 16 times 36 over 52 times 51. So again, it's the kind of thing where when I'm working with these, if I can simplify before I start multiplying, that's always helpful. Okay, so notice here 36 and 52, I can see that they're both divisible by 2, so that would be 18. This 26. Now with 18 and 26, again, they're both divisible by 2, so that would be 9, and it would be 13. Okay. I think I'm pretty, let's see. 51, how can I test and see if 51 is divisible by 3? Do you remember our divisibility rules that we studied at the beginning of the year? What? 1?
6.
6. Is 9 divisible by 3? 9 divided by 3 is 3, and 51 divided by 3. Let that go once. 3, 21, so that's 17. So now by simplifying before I multiply, I'm actually able to get these a little bit smaller numbers. So now 63 is going to be is 221. Now you could add 6 if you did not simplify it, would have had 16 times 36, 576 out of 2,652. So at large, without simplifying, you'd have 576 over 2650 and 21. What was different in activities 5 versus what did you do differently in number 5 than you did? Did that. So let's take a look. If I was my probability greater or less if I put my in. Okay, so if we look at letter G, ace than a king. I mean, sorry, not ace than a king. I'm going to have 4 out of 52 times. Four out of 52. It didn't get reduced. Good. Letter B, when a heart then a diamond. 52 times 13 out of 2. Letter C, 2 hearts in a row. Now on this one, again, I have 13 cards out of 52. I draw a card, but then I put it back. So I'm going to have out of 52 times 13 out of 52. Letter D, 2. I'm going to have 4 out of 52 times 4 out of 52. So everything basically the same. So look and see if that. Letter G, you would have 4 out of 50. And then letter H, you would have 4 out of 52 times, you would have 16 out of 52 times 6 out of 52. Okay, so it just. So that is how those. Any questions about independent and dependent? All righty. So one of the things that we're getting ready. Okay, so we're going to go through all the sheets that I've got for you. Now, one of the things that I will have you do is your packet working through. Those will be due your test. Okay, so when you turn in your test, you'll in the probability packet that we've been working on. You'll turn in this unit test I'm getting ready to give you, and you'll turn in your those 3 things due. I will put that the test is due on Thursday. If for some reason you need more time or whatever, we can discuss that. But let me go ahead and pass out the unit test review. That's what we're going to do next. All righty. Go ahead and take a look at our unit test review. But first of all, before we do that, go ahead and open back in our book. Let's kind of go back for a minute and think about everything that we have covered. I know that in the beginning, we kind of jumped sections. So let me see which one is the first. First lesson is going to be 62. Lesson 62, page 137. All right, so lesson 62 is dealing with mean. What did we say our another word for mean is? Average, good. And so how do I find an average? If I'm in a set of numbers, what am I going to do with those numbers?
You add them all together and divide them by the 9.
Perfect. Add them all together and then divide by the number of things you added together. So if I added together 5 numbers, I would add them all up, divide by 5. If I added together 3 numbers, add them all up, divide by 3. Okay, so the average, take your set of data or set of numbers, add them together, divide by the number of things you've added, and that is called your average or your mean. Okay, so the first part of your test, you will be calculating the mean for a set of numbers. Okay, let's look at lesson 63. Lesson 63 is the median. What was another word that I told you you could think of for median? Does anybody remember? Do you remember the visual image that I talked about? What could you picture in your mind when you hear median? Has to do when you're driving in a car on the interstate. Does anybody know, drive down I-65 and you think about 65, Birmingham, if you go north, if you go south, you're going toward Montgomery. Okay. Typically think about with the interstate, cars going this way, and then you got rows of cars going this way. What's down the middle? That's called the median. Okay, the strip. It's like a little strip. Sometimes it's just a concrete wall. Sometimes it be grass and flowers, whatever, trees, whatever it is. But that's the median. The median is what's in the middle. Okay, so that's how I for the word median. It's in the middle. So how do I find the median of a set of numbers? What do I have to do first? I can find the median.
You have to
Put them in order from
least to greatest.
either least to greatest, least. Okay, so it really just put them in order. That's the main thing. Make sure you've represented every single number and put it in order. Now, if I have repeating numbers, do I need to write them again? I have to make sure I represent each number that's in my set of data. So even if I have a repeating number, I still write as many times as it repeats. Okay. So then I'm going to look. If I have an odd number of data, or if I have an odd number of numbers, what do I know my median is going to be? It's going to be the very middle number, right? But what do I do if I have an even set of numbers?
You add the 2 in the middle together and divide.
Add the 2 in the middle and divide, or I find the average of those 2 middle numbers. So I have to know how to find the average to be able to find the median of an even set of numbers. Okay, add the 2 together, divide by, going to give me my median. Good job.
Hello.
If y'all have any questions as we go, yes. Hey,
I found the headphones, so the
yay.
microphone
Okay,
worked.
very good. Are you following so far? Is there anything I need
Yeah.
to back up to?
No, I'm good.
Okay,
I
perfect.
just can't start my video. That's all.
That's fine. No worries. No worries. Okay, so mean and median, and now I'm going to jump over to lesson 65 on page 143. Lesson 65 is the mode. And when I talk about the mode of a set of data, what am I talking about?
The value or value that appears number of times in the set.
So the word that's out there, the one I want to remember is most. Mode and most. Which one repeats the most? Okay. So sometimes I only have one mode. If I've got a set of numbers and I only have one number that repeats more than any other, then that's my mode. Sometimes I can have more than one number. Let's say I have one number that repeats 3 times and another number that repeats 3 times. Then I have 2 modes in that situation. Let's say I have a set of data and each number is only represented 1 time. I have no mode. So sometimes I have no mode. Sometimes I have 1 mode. Sometimes I have more than 1. Okay. Just depends on my set of data. Now let's go ahead and turn to 66. Lesson 66 is range. Okay, and so think about when I find the range, I've got a beginning and an end, and what do I do with my 2 numbers, my highest number and my lowest number? What do I do with those? Find the difference. Good. I'm going to take my larger number, subtract my smallest number. Okay, and that's my range. Now, if you put your range as 2 sets of numbers, it was between this, then you would just find the difference. Okay, just subtract them and that's your range. Any questions on that? Awesome. So your first part of your test is mean, median, mode, and range. So you're going to need to know how to do each of those. I think it sounds like y'all got a pretty good grasp of that. That's awesome. Now we're going to jump on over to lesson 70. All right, so lesson 70 is dealing with probability. And this was our introduction to probability. And we talked about how probability talks about the chance or the likelihood of an event happening. And look at how many ways that the event to happen
Miss
out of the total possible ways. Yes.
I don't have the test. So
I haven't sent it yet. Did you
Okay.
you got the unit test review that I sent you last Thursday, right?
yeah, for the probability.
Yes.
Yeah. When are we gonna need to do that?
We're going to be doing the unit test review in just a minute. Right now, I'm just going through the textbook pages that it goes along with. So we're going to do the unit review in just a little bit, and then I'll be sending you the test to do for Thursday.
Okay, so that test will be for mean, median, mode, and range.
It'll be mean, median, mode, and range, and all of the probability that we're getting ready to go over. It's all going to be in one test.
Okay, so we're gonna go over this unit.
Yes.
test.
So we just went over mean, median, mode, and range, and now we're starting probability.
Okay. Yeah. Thanks. Sorry.
Okay. Yeah, that's fine. So we're looking at the total number of ways of something that we want to happen compared to all the possible ways. And so we talked about representing that as a fraction. We want to represent it as a fraction in simplest form. Like I said, if it's a huge, big number, I'm not going to expect you to reduce if it's a big, big number. I would like to see that you made at least an effort to try to reduce it a little bit, especially if you see that they're two even numbers or whatever. But anyway, that is going to be with probability. Now let's turn to, from lesson 71, we jump over to lesson 73. We have probability and odds. Now remember, we just talked about what probability was, but when we talk about odds, we look at the number of ways that our event can occur compared to the number of ways that our event cannot occur. So that's the main big difference between probability and odds. My denominator of probability, I'm looking at all the ways that something can occur. Odds, I'm looking at all the ways that it cannot occur. So I have to subtract. I have to take my total of number of ways that it can occur, subtract the ways that I'm looking for it to occur, and that's going to be my denominator for odds. Okay. And then we talked about the odds, but that's odds in favor. And then if we're talking about odds against, we just flip-flop those two. Okay. So with odds, again, you can leave it as a fraction, or you can write it with a colon. You can do the number with the colon in the middle with another number. Whether it's a fraction or a colon, you still want to try to simplify and reduce it to simplest form if it's not just a real huge number. Okay. So that was lesson 73. Now look at lesson 74. This is the multiplication principle of counting. This is where, I'll write this down. Okay, the multiplication principle of counting was where if I have all these different possible things and I want to look at putting them together. So the example was, about the different combinations of wire, or at a fast food restaurant, picking out your meal and you get to pick an entree and a side and a drink. We take all those numbers and multiply them together to find all the possible combinations of them coming together. Okay, so this is where I just have the number of things that I've got to choose from multiplied together. Okay, so that's the multiplication principle of counting. Lesson 75, turn to page 165. Lesson 75 was combined probabilities. Okay, so combined probabilities is what we were looking at right here with independent and dependent events. When I have a dependent event, I have my first event, but then I have to multiply the second event with it. So that's an example of dealing with events and using combined probabilities. I multiply the probability of them happening. Okay. Lesson 76, permutations. Lesson 77, combinations. Okay. One of the things that I will let you do is you can write your formulas on your test to work from. Okay. So permutations and combinations, it is totally fine for you to use these formulas from the book. So the first one, my permutation, remember, with a permutation, does the order matter? So think about permutations and
Yeah,
combinations.
it does matter, right?
It does matter. With permutations, order matters. With combinations, it does not. Okay. So just like we said, if I have the number 243, if I wrote it as 432, those are two different permutations. But as far as combinations are concerned, they'd be considered the same. That would be two different permutations, but that would only be one combination because I can rearrange those numbers. The order does not matter. So that's the main thing with permutations and combinations. Permutations, order does not matter. Okay. We looked at this. This is where we have the factorial. And so n factorial is our numerator, and that's the number of the total number that's in the set. And then the denominator, where I have n minus r factorial. Remember, n is the total number and r is the number of things that you're arranging or things that you're trying to put together. Okay, so our formula is n factorial over n minus r factorial. The main thing that you will need to be able to figure out is what is my total set, what is my number of things I'm trying to arrange, and plug them into the equation to solve. All right. Combinations, very similar, except for order does not matter here. We have a slightly different formula where we're using the letter K instead of the letter R, and this is on page 169. And with combinations, K is the number of things that we're trying to arrange or we're choosing from in each group. In this situation, N is still my total number. And in this, on both equations, I have N factorial in my numerator. In my denominator of a combination, I'm going to have K factorial times N minus K factorial. For a permutation, I just have N minus R factorial in the denominator, but this time I'm going to subtract the two and still multiply by K factorial. Any questions on either of those? Awesome. 78. 78 is mutually exclusive events. This was where we said, okay, mutually exclusive events were things that, just like we talked about, having brown hair and being in the 7th grade, okay? You can have brown hair and be in the 7th grade at the same time. Those are not mutually exclusive situations. Those are not mutually exclusive events. So if I was looking at brown-haired 7th graders out of a group, then I would have to take my total number of brown-haired people, my total number of 7th graders, add them together, but then I have to subtract brown-haired 7th graders because I've already counted that one person in brown hair. I've also already counted them in the 7th grader group. So I've got to make sure to subtract when I'm looking at brown-haired 7th graders, okay? So I add my two groups together and then subtract where people fall into both categories. Now, if it's mutually exclusive, then you can only have one or the other. I can't have both of them at the same time. So in those situations, I just add them together. And then finally, independent and dependent events, lesson 79, what we were just going over, where I look at the probability of something happening, multiply by the probability of my next event, but I have to look at, does my event, my second event, depend on the results of the first one? Okay. All right, so now what we're going to do is our unit test review. Go ahead and put your name on it. And so this is this one. Okay. Let's go ahead and look at the first one. Okay, so it says, according to theoretical probability, doesn't that sound very fancy? Don't let it, overwhelm you when they throw in big words. How many times can you expect to land on green if 24 spins are taken? Okay, so let's think about this for a minute. How many green sections do I have on my spinner? 1 out of how many total? 4. So I'm going to have 1 out of 4 for each spin. How many spins do I have?
24.
I'm going to do 24 spins, right? So I've got,
Well, shouldn't you take like the size into
basically,
account as well?
well, it just says how many times can you expect to land on green? So it really doesn't matter as far as the size goes. It's just whether it's green or not. Okay. And so
But
if
wouldn't
we
the
take
size
20,
determine some of the probabilities? Because yellow is double the size of green. So it should be,
yes. So let's take a look at this. Okay. So let's look how many if we look at the sections of red and blue, okay, how many sections of green have? If red is one and blue is one, how many sections of green do I have? Okay, what if I put them
Two,
at the
yeah.
same size?
Two.
It would break
have
into
two.
two. Yeah. And then now look at yellow. How many would yellow break into?
4.
Yellow breaks into 4, right? So if I did that with it, how many now, if I'm breaking it into how many sections now?
It should have 8
So basically
sections
what I've
total.
done, I would have 8 sections. Good. So basically we had a pie like this. I know that this is yellow. I know that this is green. And then blue, then red. Okay. So basically we know that yellow's taking up half of it. So if I were to split this in half, and then I can see that green is 2 sections, then this will be yellow, and this will be yellow also. So I have 1, 2, 3, 4, 5, 6, 7, 8 total pieces now. How many of the 8 are green?
2.
Okay, so 2 out of 8 is still 1 out of 4, right? All right. So when I've got 2 out of 8, that is equal to 1 out of 4, and we do that 24 times. Okay. So if I have 1 out of 4 plus 1 out of 4 plus 1 out of 4. What am I doing there?
You're adding?
I'm adding. How many times would I have to add it? Do I really want to write that out 24 times? What's a shorter way of doing that?
Yeah. 1/4 times.
1/4 times 24. Yeah. So basically, remember, just like if I had 1/4, 1 plus 1/4, that's same as 1/4 times 2. Multiplication is repeated addition. So in this situation, I don't want to have to out 1/4 times or plus 1/4 24 times. So I'm just going to go ahead and multiply that. Okay. So remember, when I am multiplying fractions or multiplying a fraction by a whole number, what is my understood denominator of 24? 1. Any whole number has a denominator of 1. So I multiply numerator by numerator. So that's 24. 4 times 1 is 4. And what would that be simplified? What is 24 divided by 4?
6.
6. So what is my answer? A, B, C, or D? A. Good. So we had to look at that. We had to say, okay, green is 1/4 of my pie. 1/4 times 24 spins is 24 over 4, and 24 divided by 4 is 6. Let's look at number 2. If a fair number cube is rolled and a fair coin is tossed at the same time. So what they're saying when they say fair, thinking about a fair number cube is going to be what they're calling a die in this situation. And so basically it's saying that each side only has one number represented. So it's not like 2 sides or 1 and then it has a 3. It's saying that it's fair. It's got 1, 2, 3, 4, 5, 6 listed. And a fair coin means that it does not have 2 heads or 2 tails. One side's heads, one side's tails. So that's what that means. So it says if a fair number cube is rolled and a fair coin is tossed at the same time, what is the probability of rolling a 3 and flipping a heads? So we will come back and start there after the break. Go ahead and take a break.
I'm not asking nobody because I don't know if I can vote, so I'll just come and
and B. Okay, so what I've done is I've gone ahead and written some notes on the board for y'all to kind of look at all of these different things that we're talking about. So the first thing, probability, we said these are the ways that E can occur out of the total possible outcomes. Then our odds were the total of ways that E can occur out of the total of ways that E cannot occur. Multiplication principle of counting. We said that this is where we multiply all the items we had to choose from, whether it's choosing a bunch of colored wires out of a van, or it's meals and, parts of a Happy Meal, whatever it is, we multiply all of our possible things together. Combined probability, remember, this is where we multiply each event, the probability of each event together. This is what we've gone back to with independent and dependent events. But the main thing is that we knew an independent event was basic combined probability. We had to do dependent events because we had to change our denominator. Sometimes we had to change our numerator depending on what the situation was. So these are both combined probabilities. Okay, so looking at those. Fix this real quick. So we said permutations. I have n factorial over n minus r factorial. Combinations, n factorial over k times n minus k factorial. And then we have mutually exclusive events and non-mutually exclusive events. Where mutually exclusive, I just take the probability of A happening plus the probability of B, add them together. Non-mutually exclusive, I add them together, but then I have to subtract when they both happen at the same time, the number of times, okay? So what I want to do is, as we're going through these things and we see a question, I'm going to ask you, okay, well, which one of these is it? Because being able to identify which of these I've got going on, then it helps me to know how to set up my problem. Just like in the last one, these would be mutually exclusive events in our last one, because not mutually exclusive. Yeah, because each event did not happen. So when I was doing the spinner, okay, my first spin did not affect my second spin, my third, or up to 24, but we just added them. It was like repeated addition, which was the same as multiplication. All right, so in number 2, we said we have a number cube that has 6 sides. We have a coin that has 2 sides. What is the probability of rolling a 3 and flipping a heads? Okay, so what is the probability of rolling a 3 on my cube? What is that going to be?
1 out of 6.
1 out of 6. Good. What is the probability of rolling of flipping a heads?
1 out of 2.
1 out of 2. Okay, so in that situation, I have got 1 out of 6 and 1 out of 2. Now, this is an example of combined probability. So what do I do with those two fractions? With combined probability, what am I going to do with them? Multiply. Okay, so I've got 1/6 times 1 over 2. What is that answer going to be? A, B, C, or D?
A.
A. Good. 1 out of 12, because I'll multiply 1 over 6 times 1 over 2. 1 times 1 is 1. 6 times 2 is 12. Okay. If you have questions and you're not sure what to do, please be sure to let me know. Okay, look at number 3. What is the probability of flipping heads on 4 consecutive flips? Okay, so I flip once, flip twice, 3, and 4. So what's the probability of landing on it the first time,
1 out of 4.
and the second time,
1 out of 4.
and the third time,
1 out of 4.
and the fourth time?
1 out of 4.
Okay, so if I were to multiply those together for combined probability, no, I said that wrong. We said 1 out of 4. It's 1 out of 2, right?
Oh.
I don't know. I was just going right along with you. Yeah, 4. I don't know why, but anyway, I think just because it says 4 consecutive flips. Okay, so we have heads or tails, so we only have 2 options here. So 1 out of 2 is our first one. Then the second one, 1 out of 2, 1 out of 2, 1 out of 2. Combined probability. So we multiply them together. So what is 1 over 2 times 1 over 2 times 1 over 2 times 1 over 2? Close. How many times was it? It was 4 consecutive flips. So what am I multiplying 2 by? I mean, I'm multiplying, so I've got 1/2 times 1/2 times 1/2 times 1/2.
6.
Good. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So 1 out of 16, letter D. Your test will be very similar to this. So if you have questions and you're not sure how to identify the information, be sure to let me know now so we can work through it. All right, the following numbered ping pong balls are placed in a bag. A person randomly selects 2 ping pong balls. What is the probability that an even number was selected on the first pick and an odd number on the second pick? The first ball was not replaced. When you hear that, what does that make you realize we're dealing with? If the ball was not put back in, dependent events. Okay, so this tells me, all right, I've got to think about what's the probability of the first event happening. Then how does that affect the probability of the second event? So what is the probability of getting an even number?
2 out of 4.
Okay.
I mean, 2 out of 5.
2 out of 5, good, because I have a total of 5 ping pong balls. Okay, so I've got a total of 5 right here. Looking at my even numbers, the numbers 2 and 4. So 2 out of 5. Now, what is the probability of an odd number?
3 out
3 out
of 5.
of 5. Okay. Now, notice it says that the other one was not replaced though. So how many odd ones do I have? How many odd ones are there?
3.
Out of how many if we did not put the first one back? Good. So now, dependent events are an example of combined probability. I multiply the 2 together. So the probability of an even is 2/5. The probability of an odd is 3/4. Now I have to multiply them together. What's 2 times 3?
6.
And 5 times 4?
20.
And what would that be reduced? Where are they both divisible by?
3 over 2.
It's going to be 3 over what?
10.
10. Good. So letter B. All right. Let's look at number 5. What is the probability of landing on a prime number 2 times in a row? So what is the probability of landing on a prime number the first time?
2 out of 4.
2 out of 4, right? Let's look at those. What are prime numbers? They can't be divided by any other factors other than 1 in itself. So is 2 a prime factor?
Yes.
2 is my smallest prime factor. So
Oh,
remember,
never mind.
because only 1 times 2 is 2, there's nothing else. So 2 is prime. Is 3 prime? Is 4 prime? Nope, it's 5 prime. So how many of those are prime numbers? 3 out of 4, right? So I'm going to have 3 out of 4 times what? We do it 2 times in a row. So my first time is 3 out of 4. What's my second?
2 out of 3 out of
So think about this. Is this going to be an independent or dependent event? My first spin, does it affect my second spin? Does anything go away? Am I pulling anything out, not putting it back? So it's an independent event. Okay, so when I spin, I have 3 out of 4 chances of getting a prime number. When I spin it again, how many chances do I have of getting a prime? 3 out of 4. So again, I have 3 out of 4 times 3 out of 4 because it's combined probability. And what is 3 out of 4 times 3 out of 4? 9 over 16. Good. I'm trying to decide. I think it'll be easier for y'all to follow. Let me shift this over here and I'll write on these little white squares. We'll work these. And that way I can still shift back and we can look at those on the board. Okay, so let's look at number 6. What is the probability of landing on an even number twice in a row? All right, so we've got our spinner. How many evens do we have? 2 out of what?
4.
So I have 2 out of 4. And then what does that, and then, so that's my first spin. What's my second spin?
2 out of 4.
2 out of 4. Multiply 2 times 2 is?
4.
4 times 4?
16.
Now, what is that reduced?
1/4.
1/4. That was number 6. I said the first probability was 2 out of 4. The second was 2 out of 4. Multiply them together and then simplify. Let's look at number 7. Brian has a cube. How many sides does a cube have?
4. 6.
6. Yeah, so it's got the 4 sides, but then it's got the top and bottom too. So we have 6 sides. And so it's painted the following colors: blue, green, red, orange, brown, and yellow. If he rolls the cube 60 times, which of the following will most likely happen? Okay. So think about this. How many sides are there on a cube? 6. So what is the chance of blue happening?
1 out of 6.
So each color has a 1 out of 6 chance of happening, right? So what is the probability? How can I, what can I do if I look at this and I roll it 60 times? Think about what we did earlier when we had 24 times in a row and we took our probability times 24. We're going to do the same thing here. So times 60. Remember, that's going to be 60 over 1. So that's 60 over 6. So what does that equal?
10.
10. So let's look at our answer choices. A, blue will never show up. B, each of the colors will show up about 10 times. C, blue and green will show up half of the time. Or D, orange and brown will show up 25 times. Which of these is going to be my best answer?
Each of the colors.
Each of the colors will show up about 10 times. And the way I get that is because I know each one has a probability of 1 out of 6. 1 out of 6 times 60 simplifies to be 10. So that means blue has a chance of showing up 10 times, red 10 times, green 10 times, orange 10 times, brown. So when we're looking at probability, now remember, this is dealing with the chances of something happening. It doesn't mean that it's going to definitely happen this way. Okay. I think that's always the hardest part for me because I'm always going, well, what if it did this? You know, that's not what we're looking at. We're not looking at the what ifs. Okay. We're just looking at the data. We're looking at the numbers. Let's go ahead and look at.
Wait, so what was the answer again?
On
It
that
was-
one, it was letter B. They would each show
Okay.
up about 10 times. Number 8, 6 marbles in a bag. 1/2 of the marbles are red. So what does that mean? How many red marbles do I have?
3.
I have 3 red marbles out of 6 total. Okay. What is the probability of choosing 2 marbles in a row that are not red? The first pick is not replaced. What up here do I know I'm dealing with? Dependent events. My event 1 affects event 2. Event 2 depends on event 1. Okay, since every time you see where it says, if it tells you if something was replaced or something was not replaced, you know this is what we're having to focus on. All right, so we have 3 out of 6 are red, or 1/2 are red. Probability of choosing 2 marbles in a row that are not red. So if 3 out of 6 are red, how many are not red?
3.
Okay, so 3 out of 6 are not red. So that equals 1/2 as well, right? Okay, so my first time I draw, and actually we'll go ahead for this purpose, we'll go ahead and write it as, so 3 out of 6 is our first probability. I have 3 chances of not pulling a red. What is the probability of my second one?
3 out of 6.
Now, what did it tell me about my marble in this situation?
Oh,
It's not replaced, right?
So it'd be 3 out of 5.
So I've got 3 out of 5. All right, so actually, what happens to my numerator?
2.
It has to be affected, right? Because if I drew a non-red marble and kept it out, then I only have 2 non-red marbles left. So my numerator and denominator in this situation are affected. So what's 3 times 2? 6. And 6 times 5 is 30. So 6 over 30 is going to reduce to what?
1/5.
1/5. So what is my answer?
A.
Letter A. Good. Let's go ahead and turn the page. Look at number 9. I'm going to put it here. Number 9 says a student spun a spinner and recorded their results using the table shown. According to the results, what was the experimental probability that the student spun a blue? Okay, so let's think about this. How many total spins do they have? How can I figure out my total spins?
Just add up the times landed.
Yeah, we're adding them up. Okay, so we know how many were red, how many were orange, how many were blue, and how many were yellow, but I don't know my total number. So the first thing I've got to do is add them up. So I had 24, 96, 96, 24. Add them up. 4 plus 6 is 10. 10 plus 6 is 16. 16 plus 4 is 20. Put down my 0, carry my 2. 2 plus 2 is 4. 4 plus 9 is 13. 13 plus 9 is 22. And 22 plus 2 is 240. So there were 240 total spins. Okay. How many of those were blue?
96.
So there were 96 out of 240, right? Now, can this be reduced?
Yes.
What are they both divisible by?
2.
Okay, let's start with 2. What's 96 divided by 2? So let's think about this for a minute, okay? What do I know 90 divided by 2 is? What's half of 90?
45.
45. Good. What's half of 6? 3. So what's 45 and 3? 45 plus 3? 48.
48.
Okay, because so what we did is we said half of 90, half of 6, and added them together. What's half of 24?
12.
12. So what's half of 240?
120.
120. What are these both divisible by? 2. What's half of 48?
24.
24. Half of 12 is
6.
6. So half of 120 is 60. Okay. And so look at our answers. Our answers choices are 1/10, 2/5, 1/4, and 1/8. So obviously I've got to reduce, so I've got to keep on going to get my right answer. What's half of 24?
12,
Half of 60?
30,
Half of 12?
6,
Half of 30?
15.
All right, now I've got 6 out of 15. Are they divisible by 2?
No.
But what are they both divisible by?
3.
3. What's 6 divided by 3?
3.
2. And 15 divided by 3?
5.
So what's my answer?
2 out of 5.
Letter B, 2/5. Okay, so in this one, this was just a basic probability problem.
Also, I discovered 96 and 240 are both divisible by 24.
They are. Very good. So if you can pick out the faster one, so notice this, we divided by 2, we divided by 2, we divided by 2, we divided by 2, and we divided by 3. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 3 is 48. So you can see, basically, we've divided by that by the time we get to the end.
Yeah. So, but you had to divide by 24, and then you had to like cut a bit in half.
Yes.
Because
Yep.
it would have been 410. I know 310. Wait, what?
Yeah. So if you wanted to try bigger numbers, you can definitely go for it. If you want to go slow and work through it. Yeah. All right, let's look at number 10. According to the data in the chart, which of the following spinners was probably used? Okay, so let's look at our spinners. All right, look at letter A. What is our biggest portion? What is the largest section in letter A? 10A.
Oh,
What is the largest portion in letter A?
yellow,
What is the largest portion in letter B?
green,
What is the largest portion in letter C?
yellow,
All right, yellow and green look to be about the same, right? And then what about letter D?
green.
Green. So which, if we look at our chart, which one has the largest number of spins? Yellow. So which of our spinners do you think is going to match up with this chart?
Well,
Letter A, because our yellow section is the greatest section. So I have more chances of it landing on yellow because it's a larger section. So if we were to put these in order, and I said yellow was the most, then green, then blue, then red, then I can look at those and say, hey, I know that my biggest section on my spinner is yellow. Then my next largest would be green. And then red and blue are going to be about the same because they're both right at 50. Okay. So when I look at which spinner matches up with that data, that helps me to see that. Look at number 11. The 8 numbered ping pong balls are placed inside a bag. 2 balls are randomly selected. The first pick is not replaced. Dependent event. Which of the following shows how to solve finding the probability of selecting 2 composite numbers in a row? What are composite numbers?
Ones that aren't prime.
Numbers that are not prime. Good. Okay, so it has other factors other than 1 in itself. So is 1 prime or composite? Anybody remember that one?
Prime. So the ones that are composite are 4, 6, and 8.
Okay, so 4, 6, and 8 are our composite numbers. The number 1 is neither prime nor composite. It is neither, okay? So 1 is neither prime nor composite. 2 is prime. 3 is prime. So 4 is composite, 5 is prime, 6 is composite, 7 is prime, 8 is composite. So how many composites do I have out of 8? 3 out of 8. Okay, so that would be my first probability would be 3 out of 8. When I drew a second time, what would my next number be? What is my probability?
3 out of 8. No.
How is it affected if it's a dependent event?
2 out of 7.
2 out of 7. So which of these example answers would tell me how to get that answer?
A.
Letter A. My first probability was 3 out of 8. The second was 2 out of 7. So that shows me how to set that problem up. Is everybody good with that? You see how this one, it's not asking for an answer. It's asking, how do you set up the problem to get this answer? Okay. Look at number 12. Express as a decimal, the probability of landing on either red, blue, or green when given one spin. So how would I express as a decimal or as a decimal or as a percent my entire pie chart? 100%. The whole thing is 100%, right? So as a decimal, that's 1.0. What fraction of my spinner is red, blue, or green? 3/4. What decimal matches up with 3/4? 0.75, letter D. Good. Number 13, express as a decimal the probability of spinning green. So let's take a look. How much of my spinner is green? 1/4. So what is that as a decimal? 0.25. Good. So that's not letter A. Number 14, a marble is randomly selected and replaced. Another marble is randomly selected and replaced. What is the probability that both were a red marble? So how many reds do I have in my bag?
3.
Out of how many?
6.
3 out of 6, right? So 3 out of 6 is going to be my first one. My second draw, how many?
2.
Now, what did my problem tell me I do? Put it back. Okay, so I have to put it back. So now how many do I have that are red?
3.
3 out of
6.
Yeah. And what's 3 times 3?
9.
And 6 times 6?
36.
Okay, I've got 9 out of 36. Is that one of my answer choices? Nope, so I've got to simplify. What are they both divisible by?
3.
3. What else?
2. 9.
9. What's 9 divided by 9?
1.
What's 36 divided by 9?
4.
Yep. Now, if you would have said divided by 3, 9 out of 36, you would say divide by 3, divide by 3. You would have 3 out of 12. And again, you could divide by 3, divide by 3. You'd still end up with 1/4. It doesn't matter if you go with the biggest number first or work your way up to it. Either way, you're going to end up with the same answer, 1/4. Number 15, how many possible outcomes are there when rolling a pair of dice? Okay, so think about when I'm rolling a pair of dice. So think about how many possibilities do I have on one die?
6.
How many do I have on the other one?
6.
What do I have when they are combined?
36.
36, good, yeah. So I'd have to multiply them together. So I've got a total of 36 combinations. That's that combined probability. Or if you want to look at it as multiplication principle of counting, either way. But I've got 6 on the first one. I would multiply by 6 on the second one, and 6 times 6 is 36. Okay. Number 15, how many possible outcomes are there when flipping a coin and rolling a number cube? Okay, so how many possible outcomes do I have when I am flipping a coin?
2.
So with my coin, I have 2. How many possible outcomes do I have with a number cube?
6.
So how many total possibilities do I have?
12.
2 times 6 is 12. Good. So when I'm talking about my possible outcomes, I'm trying to figure out the number of possible outcomes, I'm multiplying those. Turn the page, number 17. I have Kevin, Jake, Bianca, Janine, and Eric, and they're running a race. How many possible orders can they finish the race? So think about this, okay? How many people do I have running?
5.
Okay, so if I've got 5 people, remember I can have 5, then 4, then 3, then 2, then 1, right? Or I could have 4, then 3, then 2, then 1, then 5. And I could have 3, then 2, then 1. This is going to take forever, right? Okay, this would be a permutation. Okay, so let's take a look at it. How many total do I have?
5.
Actually, never mind. Well, if we have anything like this, then I'll 1, 2, 3, 4, 5. Let's see if it does work out, because no, that wouldn't, because I wouldn't have 5 minus 5. It would be 0 and 0. Oh, yes, it would. Okay, so think about this. It would be a permutation. What is my total number?
5.
5. So 5 factorial over. In my order, how many do I have in my order?
5.
5. So I'm going to have 5 minus 5 here. Factorial. What is 5 minus 5? 0. So I have 5 factorial over 0 factorial. Do y'all remember what we learned 0 factorial is equal to?
5
What is
factorial is
0?
120, right? Not 0 factorial, but sorry.
What is 0 factorial equal to? Does anybody remember?
I mean, it's 0 times nothing, so it's just 0, or is it 1?
Look back at lesson 76.
It's 1, right?
Halfway down the page, it says note, 0 factorial equals 1. So I'm going to have 5 factorial over 1. So 5 factorial is 5 times 4 times 3 times 2 times 1. 5 times 4 is 20. 20 plus times 3 is 60. 60 times 2 is 120. And 120 divided by 1 is 120. Okay, so you do set it up just like a permutation, except for I've got 5 minus 5 in the denominator, and 0 factorial is equal to 1. Look at number 18. How many different ways can the following shapes be arranged? How many shapes do I have?
4.
I have 4. So think about, what does that mean? In this situation, I had 5 people, and how did I do that? I set it up as a permutation. So I had 5 factorial over 5 minus 5 factorial. What am I going to do in this one? How many shapes do I have? 4. So I have 4 factorial over
4
minus 4 factorial. So I'm going to have 4 factorial basically as my answer. So I've got 4 times 3 times 2 times 1. What's 4 times 3?
12.
12, and 12 times 2. 24 times 1. And there's your answer. All right. Let's look at number 19. How many permutations can be made using all of the letters in the word decimal? So how many letters do I have?
7.
7. So basically, I'm going to set it up again as 7 factorial over 7 minus 7 factorial. So basically, I'm really just looking at 7 factorial. So 7 times 6 times 5 times 4 times 3 times 2 times 1. What's 7 times 6? 42 times 5 is going to be 10. Carry my 1. So that's 210 times 4 is going to be 0, 4, 8 times 3 is going to be 0, 12. 8 times 3 is 24, 25. So that's 25, 20. We multiplied that by 3. What did I just do? 25, 20 times 2, 0, 4, 10. Carry my 1, 5. 5,040. So what letter? So look at letter C, 5,040 permutations. Mrs. Miller, number 20. Mrs. Miller wants to decorate a bulletin board in her classroom. She's going to use construction paper for the background and place a decorative border going all the way around the paper. She has red, green, yellow, blue, and orange construction paper and the same 5 colors for the border. How many ways can Mrs. Miller combine one color of background and a color of border? What do I do here with multiplication principles of counting? if I have 5 colors of paper and 5 colors of border, what do I do with those two numbers? And so that equals 25. Good. Look at number 21. I've got a menu of appetizers, entrees, and desserts. I get 1 appetizer, 1 entree, 1 dessert. How many appetizers do I have?
4.
How many entrees do I have?
5.
How many desserts?
4.
How am I going to figure out all of my possible ways?
5.
What's 4 times 5?
20.
And 20 times 4.
80.
So what's my answer?
8.
Good. Number 22, Amanda has 11 pairs of pants, 6 pairs of shoes, 15 shirts. How many possible ways can she choose 1 pair of pants, 1 pair of shoes, and a shirt? What am I going to do here? Multiply 11 times 6 times 15. All right, what's 11 times 6? 66. And so I've got 66 times 15. 6 times 5 is 30. Carry my 3. 6 times 5 is 30 plus the 3 I carried is 330. 6 times 1 is 6 and 6 times 1 is 6. And I add them up. 0, 9, 9. Multiply them all together. Multiplication principle of counting. Let's look at number 23. Alex sees 8 types of cookies at the bakery that he likes. He can only afford 2 of the 8 cookies. How many different ways can Alex choose 2 of the 8 cookies? Situation, does order matter? Does it matter if he picks an M&M cookie and then a sugar cookie or a sugar cookie and an M&M? It doesn't matter either way. He's got some good cookies, doesn't he? Okay, it doesn't matter here with order. So I've got what? A combination or a permutation? Combination. So we're using our combination formula. So what is our total number of cookies?
8.
I've got 8 total. How many is he choosing? 2. So what is my value of n and my value of k? So n factorial over k factorial times n minus k factorial. So I said we have 8 factorial over 2 factorial times 8 minus 2 factorial. So what is 8 minus 2?
6.
8 factorial over. What do we do when we're doing our factorials down here? Which one do I list out and which one do I leave as a factorial? I want to list this one out. So what's 2 factorial going to be?
2 factorial.
2 times 1, right?
Oh, right.
And then 8 minus 2 is 6. So I'm going to leave this as 6 factorial. Okay, so list out k down here and then leave what's in parentheses as the number, because now this is going to be easier to cancel out. So remember, now I have 8 factorial, so I'm going to list it as 8 times 7 times 6 factorial over 2 times 1 times 6 factorial. Those cancel. What else can cancel?
8 and 2.
8 and 2. 2 divided by 2 is 1. 8 divided by 2 is 4. So now I have 1 times 1 times 1. So my denominator is 1. What's 4 times 7?
28.
And 28 over 1 is going to simplify to be?
28.
My answer will be letter
D.
D. All right, the last one. Mr. Calhoun has 22 students. He can choose, or he chooses 2 students each day after lunch to clean up the cafeteria tables. How many possible ways can he choose 2 students? Using combination again. What is my total number of students?
22.
So n is equal to 22. What is k equal to?
2.
2. Okay. So I have 22 factorial over 2 factorial times 22 minus 2 factorial. So I'm going to list this out. I've got 22 factorial over 2 factorial times, what's 22 minus 2?
20.
20 factorial. I'm going to list out 2 factorial. So I have 2 times 1 times 20 factorial. Remember how my denominator tells me where I can stop in my numerator. So I'm going to have 22 times 21 times 20 factorial. Once I got that, those cancel. What else can cancel?
2 and 22.
2 and 22. 2 divided by 2 is 1. 22 divided by 2 is 11. So now I have 11 times 21. 11 times 21. That's going to be 1 and 1 and 2 and 2. 231, letter B. All right. So what I'm going to do is I'm going to go ahead and pass out the test. We're going to look at these real quick together. So put your name on it. Okay. What I'm going to do real quick, Hunter, so I'm going to hold this up and then I'm going to send it to you. So the first page just is mean, median, mode, and range. Okay, so you've got 5 problems here that you're going to use the set of data, calculate the mean, median, mode, and range for these 5. Now let's go ahead and take a look at our unit test. All right, these are all super similar to the practice that we just looked at. Okay, so the first one, how many times can you expect to land on blue if 64 spins are taken? All right, so what you can do is when so what is that going to be? What are we going to do there? We're going to find the probability and multiply by what? How many spins?
64.
64. So find the probability, multiply by 64. Look at number 2. If a fair number cube and a fair coin is tossed at the same time, probability of rolling an even number and flipping a tails. So just like we did in our review, we're going to look at the number of that. Okay. So these are all very, very similar. What I'm going to do is I'm going to make this open note. Okay. You can use your unit review test that we just did. You can use your textbook. You can use your notes. You can use anything that you need on this. Okay. That way, what I want you to do though, is just remembering how you've got to think about what you're going to do with each. Be sure to look at all the possible answers. Remember that my answers are in simplest form. So use the examples that we did in the review. Okay, so turn to the back, look at number 17, 18, and 19. So number 17, 18, and 19 in the test, the unit review. What did we do with the unit review in 17, 18, and 19? What type of problems were they? They were permutations. These are going to be permutations. You can use your book, use your notes, whatever you need. 20, 21, and 22, multiplication principle of counting. And then the last 2, combinations. Okay. Any questions about this? So on Thursday, your packet due, your test is due with your unit review. Okay. Any questions on that?
Wait, so we need to turn.
Alrighty, and what, hun?
We need to turn in the thing we just did. Is that what you said?
All of it will be turned in on Thursday with your test. Yes.
Okay.
So the unit review that we just did, and then I'm getting ready to send you.
Yeah, and the packet that we finished.
Yes, the packet that we started on when we started back virtually, that we just finished up today with independent and dependent events.
Okay.
So I'm going to get ready and send you this test. All right. If you have any questions, be sure to let me know. If not, we've got about 3 minutes before the bell rings. Your dad's here? Sure, you can go. All right, have a good couple of days and I'll see you Thursday. All right, Hunter, so I will send you this just a minute. And do you have any questions before you go, Hunter?
Nope.
All righty. Well, very good. Well, I hope you guys have a great weekend and I will see you on Thursday.
Bye.
Okay. All right. Bye-bye. And I'll send this in just a minute. Be watching for it. Okay.
Okay.
All right. Thanks, bud. All right. All right.